Cool. Thank you for joining just before lunch. So I will try to be fast, and then we can go and get a bit fat. My name is Oscar. I work for PyLogic. I'm an architect there. This is my Twitter handle, so follow me if you want. So what's this about? Scaling. I think scaling, like many technological things, are about people in the first term. If you don't care about scaling, well, good luck. There's also some technology involved, some tools. Basically, I wanted to see how can we scale PyLogic, so I looked at how do other people scale, how does Instagram scale, how does Discuss scale, for example. There's a lot of talks about them. So, and I tried to find what is the easiest way to scale an existing system. So what about people? As I said, you have to care about scaling. If you just write some system that won't scale in a million years, then it will be very difficult to bring that in. But you also need a lot of focus. Because it's very easy to start making something from the ground up, scaling a lot of systems, a very complicated communication. Maybe you don't need all that. It's also very important to automate and to test. If you don't automate things, you will die. You will be just all the time doing the same things manually. And it's very important to test, because otherwise you just waste time clicking around. It's also very important to have a shared brain, so to do, for example, code reviews between team members and make sure that everything stays in the shared brain memory of the team, so there's not one single guru that knows about the tricky part. And you need to finish things and not repeat yourself. So by finish, I mean make things that you're not constantly returning to because they broke, because they also kill you. This is not specifically about scaling, but just about doing software engineering in general. And don't repeat yourself. I mean, don't build your own task queue, probably. There's a lot of them already built. At the same time, if you already have a solution, something that works, something that you could maybe change a little bit and start using it as a task queue, that may be worth it, because you already are using that tool, it already works for you, you already know it, so it can get you quickly started with using a task queue, for example. What about tech? You should design things so that they are clonable. And by this I mean if you have a system that keeps a lot of state, it depends tightly on one database, you cannot easily just make a copy of it and run the system like this. But we can go back in time to last year, my talk of last year. I spoke about the virtual queue system that we use at PyLogic, which is, if you go to buy a very popular event that has a lot of visitors, hundreds of thousands of visitors per second, you're put in a queue and you get a position in a queue, and then you wait there, and in the end, you go to the front end of PyLogic to buy your tickets. This is made as a bunch of clonable things. They're very simple queue instances. They don't keep any state. Well, they keep some state. They share it among them. They are completely identical. And if one dies, then the others know how to share among themselves. If it comes back in life, then they know that, oh, that one is back. We will share the state with them. Of course, they need some state because they need to know how many people are there waiting, etc. But they are very simple systems, and you can make many if you need more. You can kill some if you don't need them. They don't care. So this is, if you have a system that is like this, then that's very easy to scale. So if you can divide your system in parts and make some parts like this, then you already won that part of the war. So continuing with the tech, separate your system in pieces. We will talk about this soon. It's nice to have API for these pieces. It also makes them easier to test. Offload everything. Don't send your email yourself if you don't have to. If you're generating PDFs, maybe there's a system that does this, some other company that already does this. The least that you do, the better. And measure everything, because you cannot just go and say, I need to scale very fast. Everything needs to be fast. Well, how do you know? How do you know that this thing is used by a lot of people and therefore should be scalable? Maybe you don't need to scale this part. It's also useful if you do an experiment, you need to know if it worked and what did you get out of it. So measure everything. If you are not using StatsD and Graphite, use it. It's very easy to get started. So what about types of tasks? When you do things, when your system does things, there's different kinds of things that you do. There's things that you want to do in real time. Is this? Yeah. that you need to do in real time. For example, if you're buying a ticket at PayLogic and you choose a seat, well, that seat needs to be locked for you right now. You cannot do it as soon as possible. It has to be right now. There's other things, other tasks that need to happen as soon as possible. So when you, I don't know, when you buy a ticket, you want to, as soon as possible, well, store better. When you start paying, you want to start the payment on the payment processor as soon as possible. You don't want to wait a lot for it. It needs to look like it's real time, but it doesn't need to be right now. It's not like the locking of the seat. And there's a third type of task that you can do when you have time. So when do I register this sale on the PayLogic system so that we pay the merchants, etc.? Well, when you have time, as soon as you can, but it's not as critical as the other two tasks. So these things that need to happen as soon as possible, but not right now, and the other things that need to happen, well, when you have time, these can be done asynchronously. And typically, these things are done in the request-response loop, as we will see later. Maybe it's good to take them out of there synchronously. So how does Instagram's feed work, for example? I found it interesting. If you're following people in Instagram, you get a Redis queue for yourself. And then when the people that you follow post some images, they put these images, these IDs, in your queue in Redis. So this means many things. One is that when somebody posts a new image, they don't have to now go search all the followers, start putting things there. They have an asynchronous system that does it whenever it can, as soon as possible, but not urgently. They also use chain tasks, so a small task that completes reasonably soon. If a task fails, it's not a big deal, because it's not that the whole thing failed, just a little part of it failed. And what they do is these tasks schedule each other. The one task does a bit of work and schedules the next task. I had a bit of slides about Celery, but I think I can just skip it about, well. So let's imagine a system of hotel reservations. I thought, let's step away from PayLogic and from everything. Let's imagine that we have a system of hotel reservations. It looks like this according to the corporate website. It looks like this according to the developers. So they have a system that does everything. It does the UI, the room locking, calculates availability, it manages the registrations, it sends emails, generates the PDF with invoices, it pays to the merchants, it handles the payments, it lets people log in, etc. Who here has a system that is more or less like this? Ah, nice. We should talk later. But it's funny, when we program, we don't do this. We don't write a huge function that does everything. Well, maybe at the beginning when we start, we have an idea, I want to try this out. I want to just see if this works. I'll just make some code, just quickly test it. OK. But we do this. We do have a server that does everything. It does the front-end UI, and it locks the rooms in the case of the hotel registration. And it calculates the room availability, and it locks the rooms temporarily while you're choosing it. Or it also processes the payments and mail and generates the invoices on the request-response loop. It's so much it doesn't even fit in the slide. So why do we do one thing and not the other one? And then we say, no, we can scale, come on, because we can have a lot of front ends. But yeah, but in the end, all these front ends talk to one central database, because for one, you're locking that room. So that has to be only one guy who does this locking. And scaling the database is harder. Of course, you can have some database slaves. Maybe you can have master-master replication, or you can shard, but yeah, shard everything. But sharding is not there? Oh yeah, now yes. But it's difficult because you have only one system that does everything, and now shard this guy. Well, I don't know, good luck. This is really difficult. And for this, to exemplify this more, I have this other slide. I don't know if it will work, because it has some sound in it. So, this music, it sounds a bit sad and melancholic. And one of the reasons why it sounds sad and melancholic is because it's using a minor scale. So how would this work if we would play the same song in a major scale? It would sound like this. It's almost like a Christmas song. It's nice. If they sing this one at your birthday, you're happy. If they sing the other one at your birthday, maybe you should check there's no horse in your bed. So how do we go from a minor scale that we just saw to a major scale that will make us happy and our users happy? Well, of course, we want to go to the major scale and do a lot of fun stuff, but we have a real system with real database there, all the servers. You cannot just go and rewrite everything. But as we said before, it's good to split things, to split your system into different parts that do different things, because some of them you can clone, others you can't. So let's look more into that. How do you split things? One way to split things is by responsibility. What are they doing? Also, between are they keeping a state or not? Because as we saw, if you keep state, that's difficult. Also, what type of system it is, and by this I mean, does it need to be unique? Is it doing like a mutex, or is it like the data store where everything ends up, all the sales end up there? So if you shard this one, then it's going to be difficult to obtain data from there to make reports. We also saw the types of tasks, real time, as soon as possible, whenever you can. We saw this before. So I was thinking, I want to split, well, how do we split this? One way, going berserk, just a lot of things. We just split it in all the things that it does. We have different servers, different services. They talk to each other with APIs. This is going to take a lot of time, and we need to focus. We want to do an experiment. But we have limited time to do it. We cannot just rewrite everything. Let's look at the clonability of systems. The database, the main database is not really clonable. It keeps the state of the system. It does not do mutex, though, so you could do something there. Here's where the payouts to your hotels, in this case, come from. The reports, you could split it, you could do sharding on it, and then the reports would be more difficult, but do you need to clone this guy? Maybe this guy is low, but it's okay that it's low because you're not using it in real time. What about the system that makes sure that you don't sell the same room twice? Well, this one, it's a mutex, so it's difficult to clone. Although this guy also calculates which rooms are available. And this needs to be shown to the users as soon as possible, but not in real time. Who cares if I click now on this room and the number of available rooms is still 10 for a second until it goes to 9? I don't care. Everybody expects that this is changing all the time. You could chart this guy by country, by hotel chain, etc. Maybe you don't need it if it's already a separate system. We'll look at it later. In the end, we have the front ends. The front end servers, they keep no state. You can clone them as much as you want. But I'm tricking a bit because the front-end servers, in the end, they all talk to the same database, which keeps the state and which actually is holding back your scaling. So how do we take this and we make it scalable but in an easy step? And what do I mean by easy step? Well, it's very important to experiment. As they say, there is no knowledge in the office. There's only opinion. If you want to have knowledge, you have to go out and do experiments. So we want to take easy steps that need as little change as possible. You can't rewrite the whole application just to try if you can scale. You can shut down the shop for 3 months or for a year. So we also want to reuse as much of what we already have for the same reason. We want it to be an intrusive so that it can run together with the current system. We try to scale, and we actually send users to the new system, the scaled system, see if it works. If it doesn't work, we just redirect them to the old system. It's okay. But if it works, they can stay there. We can see how much faster it is, how much capacity we gain from this experiment. And we need to measure what we gain from it. As I said before, put some measuring tool like LastStatsD, for example. But we also want a simple step that goes in the right direction. That is not, okay, we did this experiment here, but in the real world, we need to do something completely different, because then the information that we got from our experiment is useless. Not completely useless, but. So we want to do small steps. We start with what we already have, front end that is doing everything and talking to one database, and we clone it. Now we have 3. Well, this scaled. That was easy. But it has some problems. For one, it oversells. If we do it like this, you will lock the same room 3 times. Well, okay, it's a problem. There's also the problem of configuration. You set up a new hotel, but you need to do it 3 times. So that's not very nice. Reporting is also bad. Now you have to go to 3 places to get your report. Why? The payout to your hotels is also bad. So, okay, we have these problems. Let's see if we can solve them. One thing that we could do is we could extract the part of the system that does the locking of the rooms to separate system. It could even be one of these everything front ends that is only used, from which only the part of locking the room is used. Logging, I made it red because this needs to be real time. You click on that room and it's for you. Reading which rooms are available, etc. This doesn't need to be real time. You can wait a bit, or the changes on the availability of rooms, that they don't need to be visible in real time for all the users. It's convenient if they are available as soon as possible, but it doesn't have to be real time. Adding a separate system for this also helps you in the sense that you can choose, you're free to choose the technology here. You're no longer changing the whole system with the single database that did everything, and you can just change that database for something else because everything needs to migrate to that. Here you can use something faster, like Redis, for example. Oh yeah, I have a slide for that. So you can choose the best technology. It's decoupled from the rest of your system. You can add an API to it, which will make it easier to test, easier to use. So we solved that problem of overselling. Now we are not overselling anymore. Okay, we have another problem, which is the problem of configuration, that you had to go through to 3 systems to configure them. Well, we could take one of these guys, or your existing backend server, better, where your back office is, where you configure the rooms, and make it send the settings when they change to all the front ends. It could just go front end by front end and send the settings there. Just you'll have to add some API call to each front end so that they can receive this new information. Or you could put this configuration in a queue, and then the front ends decide when to pull from that queue. And queues are handy because, for one, it's the server that decides how much data it wants to handle, not the one sending the data. So, for example, if you go to the front end of this hotel and you start booking rooms like crazy with some scripts, the server will die. But if there is a queue in between, you put all your requests to lock rooms in the queue, and the server will decide how much of this wants to handle. I can handle 10 per second. Well, I handle 10 per second. The queue may be getting very full, and the users may be waiting, but the server doesn't die. So, good. Now, how do we go about the reporting and the payout of these hotels? Well, we have this initial system that we had at the beginning. We have this front end with the single database. So we will modify it. Did it modify itself? No. We will add something there small, some sales synchronization that will. It's an API entry point where, when somebody else is selling stuff, it can tell this system, I sold this room to this guy. Just so you know, I handled the sale, don't worry. The money is in the account, everything is done. You just put it in your books. And we will call this guy the sales backend. So we reuse the same front end we had before. We just add a little part to it. We give it another name. This one doesn't need to handle customers anymore, but it can. So this thing can run alongside your existing system. It's the same thing. We're just selling things. We're selling things away from the system, but when we actually do the sale, we send the sale to this sales backend, which will put in the database like any regular sale. And this takes care of the reporting and payout problems, because from this moment on, your sale is just a normal sale. It ends up in the same main database, etc., which is still slow. But this thing of registering the sale is a task that has to happen whenever you have time. As soon as you can, but it's not real-time critical stuff. So this was very fast. If you want to know more, I recommend that you Google for Discuss, Instagram, Braintree, for example. They are companies that are or did recently effort in scaling themselves. And there's very interesting talks on how they did it. This is where I got the ideas from this talk, and also from PyLogic, of course. So, any questions or any answers? Anyone here using Celery, for example? What are you using it for?
For just clones, task processing, everything. I mean,
Everything that takes a long time.
Cool. Which backend?
RabbitMQ.
Did you have any problems setting with tasks that get forgotten or?
not really, but once in a while I have to purge a queue because something went died just and you purge it.
We should talk. Any more answers? Okay, thank you for your. Oh, who is there? That person at the back.
Why is Redis a bad choice for a salary backend? You skipped the slide.
Oh, okay, sure, we can go back. It's not a bad choice, it has some bad things like all choices. Where is it? It's so oh yeah. It's good because it's fast. It's bad because it does polling for task distribution, which may be okay for you, depending on how you use it. The replication is a bit messy. Messier than RabbitMQ, where it just works. And since the storage is in memory, then you have a memory limit on your tasks. But maybe that's also okay for you. So, yes.
Go back to the Redis slide.
Redis slide.
Polling for task distribution, you know you have a blocking fault.
Okay, that's interesting. I will look into that. Thank you.
What did you say? You have a blocking fault in Redis.
Oh, okay.
So that's not polling, it's just long polling.
Yeah, interesting.
I don't know, but it's there, so it should.
Yeah, good point. Yes, Mr. Armin.
Small note to Redis, it doesn't do acknowledgements. So if you lose your task, you lose your task. I think that's the only problem Redis actually has.
That's a good point, yeah.
The nice thing is that in theory, you have the problem anywhere anyway, so you can always lose a request. So if you build your system that the client can just go try it, it's fine.
Yeah, I think that. Yeah. Not really, yes? Yeah, I've heard about that, yeah. But yeah, this problem of losing tasks, you always must choose between doing the task maybe no times or one, or doing the task once or maybe twice. There's no way to get around that. Anything else, or just food? Okay, thank you for joining. I can go to the end.